Before I go through example 2 with you, I think it's important to mention that you want to memorize these side lengths for a 45, 45, 90 triangle, reference triangle. Whenever we draw a terminal ray, we are going to let that terminal ray or that length of the radius be 2. So not 1 like on the unit circle, but 2. You could use 1 for your radius if you wanted to, but then all 3 of these lengths would have to be cut in half. Remember that on a 45, 45, 90 triangle, the 2 legs are the same length, and to get from the leg to the hypotenuse, you multiply by the square root of 2. Well, root 2 times root 2 is just 2. If the radius is 2, to go backwards, we divide by root 2. And 2 divided by root 2 is also root 2. So just memorize these lengths. So what you'll have is in each quadrant, depending on where your terminal ray is, if you have a 45-degree reference angle, all 4 of these triangles are congruent. So here's the steps. I'll explain the steps as I go through them. For example, 1a. So if we want to find the cosine of 45 degrees, the first step, to draw the terminal ray. The terminal ray would be right here in quadrant 1. The second step, drop down the length perpendicular to the x-axis. So from this terminal ray, this point, drop down or up. I should put down or up. It should say down or up here, depending on which quadrant we're in. So we drop down the perpendicular to the x-axis. Then I'm going to label the reference angles and the measures of each sides in the reference triangle. So the reference angle is 45 degrees. The reference triangle has lengths 2 for the hypotenuse or the radius, root 2 for each one of the legs, just like I showed you here. So that means that the cosine of 45 degrees will be the x-coordinate here divided by the length of the radius. And the x-coordinate here is the length of this side. This is x, root 2. And the radius length is 2, so it's root 2 over 2. That is the exact value of the cosine of 45 degrees. If you put cosine of 45 degrees into your calculator, you'll get a decimal approximation of about 0.707. But we want to give the exact value, root 2 over 2. Anytime you're asked to find the cosine or sine or tangent of an angle measure and give its exact value, it will either be, that angle measure will be a multiple of 45 degrees or a multiple of 30 degrees. This is also a multiple of 45 degrees, 135 degrees. There's just 3 sets of 45 degrees. So sine of 135 degrees, the first thing I'm going to do, step 1, draw the terminal ray. The terminal ray will be in quadrant 2, 135-degree rotation of the initial ray. Second step, drop down the perpendicular to the x-axis. And then label the reference angle, which is 45 degrees, because the reference angle is always the angle that's in between the x-axis and the terminal ray. That reference angle is 45 degrees. So this is a 45, 45, 90 triangle where the radius has a length, or the hypotenuse has a length of 2, and each leg is square root of 2. The only difference is I'm going to put negative root 2 for this length over here. Even though the length is positive, because this represents the x-coordinate in the second quadrant, this length is going to be negative root 2. So the sine of 135 is the y value, root 2, divided by the length of the radius, which is 2, so I get root 2 over 2. To find the tangent of 315 degrees, I rotate the initial ray 315 degrees with the terminal ray ending right here in quadrant 4. The reference angle is the angle measured between that terminal ray and the x-axis, which will be 45 degrees. So step 1, draw the terminal ray, which is done. Step 2, draw the perpendicular up to the x-axis. Fill in the lengths, 2 for the hypotenuse, negative root 2 for the y-coordinate, and positive root 2 for the x-coordinate. Tangent is defined as the y-coordinate divided by the x-coordinate. So you will have y over x, which is going to be negative root 2 over positive root 2. and that simplifies to -1. I had them do these two on their own, but you can take a look at them later. To do tangent of pi over 4 is just 45 degrees. So again, first step, 45-degree rotation or pi over 4 rotation, draw the terminal ray. Step 2, draw the perpendicular to the x-axis. Step 3, fill in the angle measures and side lengths. And the tangent ratio is the y-coordinate divided by the x-coordinate. You could also think of it as the tangent of this angle measure is the opposite over adjacent. So the opposite over adjacent is the same thing as the y divided by the x. So it'll be √2 over 2, which simplifies to 1.